heating curve, and the kinetic particle theory. Matter and its interconversions. We covered this in our last video on matter. Just in case you haven't seen our video on matter, you may want to pause this, take a look at that, and then continue. Now let's move on. A quick summary on matter and its interconversions. Matter exists in three physical phases: solid, liquid, and gas. Matter can change its state when heat is applied or removed. The energy of the particles change when heat is applied or removed. This change in energy would affect the movement of the particles and the forces of attraction holding the particles together. A quick summary on the interconversions shown in this diagram. When heat is taken in, a solid can change to a liquid or to a gas. A liquid can change to a gas as it takes in heat. The particles gain more kinetic energy and move further apart from each other. However, when you cool these substances, a gas can turn to a liquid and then to a solid. Or in the case of substances that can sublime, the gas can change directly to a solid state. The particle model. The particle model shows us how the particles of matter are arranged. In solids, the particles are tightly packed together and they vibrate at a fixed point. In liquids, the particles have some spaces between them, just enough to allow them flow. This means that liquid particles are further apart from each other as compared to the solid particles. Gas particles are spread out and they move randomly in all directions. When the particles are tightly packed together, it shows that they have very strong forces of attraction holding them in place. This is why solids only vibrate at a fixed point. When particles are further apart from each other, the forces of attraction holding them together are weak. Comparing the properties of these different states of matter using the particle model, there are 4 things you will need to cover when you do this. Number 1, arrangement of particles. 2, the cohesive forces between particles. 3, the movement of the particles. And 4, the kinetic energy of the particles. Arrangement of particles. In solids, the particles are tightly packed together. In liquids, they are close to each other but not as tightly as in solids. In gases, they are far apart. 2, cohesive forces. Cohesive forces in solids are very strong. In liquids, moderate, and in gases, very little. Movement of particles. Solid particles vibrate at a fixed point. Liquid particles can slide over each other. Gas particles maintain random movement in all directions. Going by the properties that we've discussed in the first 3, we can easily infer that gas particles have very high kinetic energy. Solid particles have low kinetic energy, whereas liquid particles have moderate kinetic energy. Now let's relate this to the kinetic particle theory. This theory states that the particles of matter are always moving and that the particles possess kinetic energy. Heating or cooling changes the kinetic energy of particles. This change in kinetic energy of particles will determine how the particle will move and the strength of the cohesive forces holding the particles together. Heating, which means we are adding energy, would lead to an increase in kinetic energy of particles, decrease in cohesive forces between particles, faster movement of particles, and a loose arrangement of the particles. This therefore explains why heating up a solid can change it to a liquid or to a gas. Removing energy, that is cooling, will lead to a decrease in kinetic energy of the particles. And as the kinetic energy of the particles decreases, the cohesive forces holding the particles together would increase. The particles will move more slowly as they lack kinetic energy, and they will get tightly packed together. So a gas can change to a liquid can change to a solid, which particles vibrate at a fixed point. The heating curve. The heating curve is a graphical representation of changes of state of a substance. It shows us what happens when a substance is being heated or cooled. When you draw a heating curve, the temperature is plotted on the y-axis and time is plotted on the x-axis. The plotted coordinates are joined with slanted and horizontal lines. Now, let's take a look at the heating curve. The slanted lines are showing us that the temperature of the particles are increasing constantly, while the horizontal lines are showing us regions where the temperature of the particles do not change. These points have been represented with the letters A and B. A showing the melting point of the particle and B the boiling point. At point A, the particle changes its state from solid to liquid, and at point B, changes from liquid to gas. Now, what would this look like when we decide to reverse the process by cooling? The temperature of the substance would decrease until it has changed back to the solid state. At first, the temperature decreases until it gets to point A, where the gas begins to condense. At this point, the temperature will no longer change until the gas completely condenses to the liquid state. Then the temperature of the liquid will begin to decrease once again until it gets to point B, where the liquid begins to freeze. After the liquid is frozen, the temperature of the solid will begin to decrease once again. The temperature at which a substance condenses is similar to the boiling point, and the temperature at which a substance freezes is similar to the melting point. The boiling point is the temperature at which a substance begins to boil, and the melting point the temperature at which a substance begins to melt. These temperature values are unique to every substance and can be used to identify substances and their purity. Let's recap. Matter can change its state when it is heated or cooled. The particle model shows us The solid's particles are tightly packed together and vibrate at a fixed point. The liquid particles are free and can flow, whereas gas particles spread out and move randomly in all directions. The kinetic particle theory states that particles of matter are always moving and that they possess kinetic energy. This theory can be used to explain the behavior of matter as it changes state. The heating curve is a graph that shows us how temperature changes when substances move from one phase to another, and the boiling and melting points of substances are unique to them and can be used to identify the substances. See you in our next lesson.